Hello everyone and welcome back. So this time we're going to be going over the group problem, which it's an online class right now, so not really for groups. However, if you're watching this and this is an in-person class now, cool. Find somebody to do this problem with them. Okay, but moving on. So we have this group problem. And this one's going to be a little more difficult because we're going to need two free body diagrams. Now, I know like in the last problem, we could have had a second free body diagram, but it was so simple we didn't really need it. This time we're going to need one. So what we're going to have to do is you're going to have to solve the problem right here. Do one free body diagram to get this force. And then you're going to solve it right here. Because we're going to find the force in every single cable. There's 1, 2, 3, 4, 5 cables. And only one of them can we find out just by the problem statement. So 5 unknowns, way too much for our 2 equations problem. Now the thing is, if you have more than 2 unknowns, it's just per point that you have 2 equations. If you have multiple points, then you can have more equations. So what's your plan? Your plan is you're going to draw a free body diagram for point D. You can then solve for this force and then use that to solve for everything else. Now we have different ways of showing forces. We have angles. And we also have our nice little slope triangle. Remember that slope triangle makes things really super easy. So make sure that you use it to your advantage. Okay, with that being said, now is the time when you go and try it on your own. Don't cheat, don't jump forward and look at that next PowerPoint slide. Go ahead and try it. So in 3, 2, 1. Okay, hopefully you've paused. Hopefully you've gone and tried it. And come back. If you haven't, come on, you're supposed to do that. But that's okay. So with that in mind, let's get to it. So first off, we have our first free body diagram, first, at point D. So we cut it out, and then we have our 3 forces. Because ropes can only do a pulling force, they're all pointed away from our point D. Now lucky for us, we already knew the mass of the lamp, and therefore we could figure out what the force was in this little rope. It's going to be equal to the mass times gravity, that'll be in newtons, 20 times 9.81. Beyond that, we have 2 unknowns, we have 2 equations we should be able to solve. So what we're going to need to do is we need to break force DE, which I'm just going to call force E right now to make things a little bit simpler, into its x and y component. Looks something like this. So force EY right here. And this will be force EX. This will be 30 degrees. And this will be force E. Okay, so with those, we can then begin to solve. So once again, force EX is on the adjacent side, so that'll be cosine of theta. Force EY is on the opposite side, so that will be sine of theta. So if I want to solve for force EX, I want to do both of them because we've done this so many times now. It's going to be equal to force E times cosine of 30 degrees. You know what? I'll go ahead and do it. And force EY, so the opposite side will be force E times sine of 30 degrees. Okay, now that we've done that, we can solve for them and we can get force DE, this one right here, which I was calling force E. And we can also solve for force CD, which is going to be 340 newtons and 392 newtons. Now that's good for the first point. We need to solve these last 2 ropes, AC and BC. So once again, we have another free body diagram. We know what this force is from our first free body diagram. We have 2 unknowns, and luckily for us, we have 2 equations. This time we're going to have to break up both of the forces into components because neither of them is pointing along a nice straight direction. But that's okay. That's not going to be too terribly difficult to do. Be very careful though, this force right here gives you an angle that's not to the x-axis. So you're going to have to use your trig function slightly differently. So we've done this one before. We'll just focus on force BC this time because it's a little bit different. So let's write it just like I did. And I have force, we'll just call it force B, just make things simpler. Force BY right here and force BX right here. As a note, force BX is negative because it's pointing to the left. This is negative. And this one right here will be force B. So with that in mind, we have 45 degrees here. Now, it doesn't really actually matter because it's 45 degrees. You can use either trig function. They'll give you the same thing. However, if we're doing it right, our force Bx is on the opposite side because of what angle we chose. And so force Bx is equal to force B sine of 45. And force By is equal to force B cosine of 45 because it's on the adjacent side. Be very careful because that can change. So in this case, with 45 degrees, you could have messed up and it would still work. But if it was 30 degrees or something else, it would not have worked. Okay, so we plug those in, then we add all of the x components together. Keeping in mind that force Bx and force Ax will be negative. We add all the y components together. We have two equations, two unknowns we can solve. And we have to use a little bit of algebra here. That's the big thing about these problems. There will be a little bit of algebra. You're always trying to make it so you can avoid algebra if possible. In this case, we really can't. We're going to have to use a little bit of algebra to solve. But if you solve for one and then plug into your second equation, you can do that. You can also use your calculator to solve these kinds of equations. You've got a TI-83 or something like that. They can actually solve sets of equations. So use that to your advantage. Let it help you. And with that, we get that force BC is 275 newtons and force AC is 243 newtons. And that is reasonable. That makes a lot of sense because if you look at the angle for this and for this, it's fairly similar. So you would guess that their magnitude would be fairly similar as well. Okay, with that, we have finished this little problem. I hope this helped you. Just remember this free body diagram, so you have to make sure you take into account everything and that you're very careful about the direction you draw your arrows. So, with that, I'll see all of you next time. Bye-bye.